Okay, so previously we discussed about the basic concept of atmospheric pressure, that actually what atmospheric pressure is, right? And the next thing is that is related to the value of atmospheric pressure and what is the meaning of that and what is the purpose behind using that tube with that container of mercury liquid, and why we are using that height of that liquid. Because if we just to measure that height, you can see that this h gives you the height of the liquid level, and it is starting from the surface of the liquid. So you can see that your level of height is actually starting from the surface of the liquid in the container to the maximum height of the liquid into the tube, right? And normally, if we
Yeah.
talk about this tube, you observe that in practical experiment that we observe in the video. So there is a value of 74, right? But she is performing in a lab, and she's not, she's just showing you the practical demonstration. So maybe some, there are some precautions also, and you know that there will always a slight error in using the instrument. So your actual value is different from your calculated value sometimes, right? But your calculated values is still close to the actual value, right? So what is the value on that scale that we observe from the video, that is equals to 74, right? Okay. And normally it is equal to 76 centimeter if we perform this experiment in very ideal condition. So in very ideal condition, we can say that ideal condition mean there will be no error, right? Exact value, that is the original value for atmospheric pressure, that what height we are going to get in the atmospheric pressure with the help of mercury barometer. So in ideal condition, we can say that the value of h will be equal to 76 centimeter, right? So this is the ideal condition. And in the experiment that we observed, the value is 74, very close to the actual one, right? But we know there are some errors and we need to follow some precautions while performing experiment in the lab, but still it is very close to the ideal condition. So in ideal condition, the value of height in the tube will always equals to 76 centimeters, right?
Sir, in the video it was 74.
Yes, that I was telling you, because when we perform experiments, because in your exam specification there is a paper of P3 that is related to practical, but most of the student go with the ATP. So that's why we don't have idea to perform experiment in labs, because when we are performing experiment in labs, so it also depends upon the condition of the apparatus. Just like if we are using a same apparatus for different time, like again and again we are using same apparatus and we are not washing that apparatus properly, and maybe that iron stand was not properly leveled. So these are some factors that will change your actual value, uh, your experimental value from the actual one, right? So we not always get
Yeah.
the same exact value, but very close to the exact one, right? You can see that she is performing that experiment in a very quick way, so that's why she got 74. But for ideal condition, that is 76. I'm telling you the ideal condition because that will give you the concept that the experiment that we observed is almost close to the actual one, the real value of the height in the tube, right? So
Yes, sir.
normally what we do, let's suppose if we want to add the atmospheric pressure, or we can say that if we want to include the value of atmospheric pressure in your questions or in your examples, because now we don't need to discuss about very much detail, because already I told you that your topic was reduced right now. So we don't need to discuss very much detail about this atmospheric pressure. We only need to know about that how to measure the atmospheric pressure using height, with the help of mercury barometer. And the concept of height is that you need to know about the level of the height. So we need to measure this height from,
Bottom of the tube to the maximum level of water.
now you can see that the bottom of the tube is immersed into the liquid, right? And we take the height from the surface of the liquid, right? So I am writing the bottom from bottom side. We need to measure,
s- Surface of the liquid.
yes, measure from the surface of liquid in the container. And might be this point is a very small one and maybe you ignore this point, but this point is very much important. And I will also show you the question that many mcqs questions are related to this value of h. They just give you different diagram with different marking of h, and they just ask you that which value of h helps you to find out the atmospheric pressure. So you need to identify the correct identification of h in the diagrams that was given in your option, right? So this value of h is not the simple one. So you need to remember this value, because this
So
is,
it's from the surface of the liquid in the container to the
and if you talk
maximum point of liquid in the tube.
in the tube, because you know that if we use water, so there will be upper meniscus and lower meniscus, right? So we are using mercury, so there will be no upper meniscus and lower meniscus. So it
So,
will be like a
so, sir, if we have a question on writing how to do this, do we say liquid or mercury?
we are using mercury, and they never ask about the liquid, right? Because this topic is now very
So
much,
in the answer, we'd use the term mercury, right?
yes, we are using mercury, and you already know the reason that if we are using water, so water will, some drop of water will stick to the wall,
Yeah.
so
So
that
can you
will
change this?
for a height. Yes,
Can you change this?
surface of the liquid in the container. Okay,
Yeah,
you
you
can
can.
also write that one as mercury, because we are
Okay.
using a journal, because sometimes we used to explain this experiment with the help of water in schools, because in laboratories sometimes mercury is not available. So in ideal condition we use mercury as a liquid.
Okay.
So mercury is more accurate.
Yes, actually, there is a topic of thermometer in your syllabus before May June 23, and in that topic, there is a complete comparison between that why we use mercury in thermometer rather than water, because water is the cheap and easily available liquid. So why we are not using water? So the main differences between that water and mercury is that mercury, the melt boiling point of mercury is very high as compared to liquid water, right? So if we are performing this experiment, let's suppose at high temperature, so mercury will not start to evaporate, right? Because boiling point is very much high, so mercury will evaporate at very high temperature, right, as compared to water, because you know water will evaporate at normal condition also. So that's why we are not using water as a liquid in this experiment. Second thing is, water will stick to the wall of the container and stick to the wall of the tube also, right? So you will find if you just take a bottle and just flip it or just make it inverted, so you observe that there are some drops of water on the top side of the bottle and the side walls of the bottle. So that's why that will also change the height and level of the liquid in the container, right? So these are the major factors that actually we use mercury in this experiment, not the water. Okay.
So isn't it also because mercury doesn't stick to the walls
Yes.
like water does?
So
Okay.
water does stick to the wall, so mercury will not. So that's
In
why,
the exam, would it ask us for reasons why we use mercury and not water?
no, I, that's why I'm not writing the reason, because that was included in the last exam of 22. Now those topics are excluded because there is a complete topic of mercury and water difference, why we are using mercury in thermometer. So actually that is the part of thermometer. So thermometer section is completely removed. So that's why I'm not writing this, because that will confuse you that are we going to write an exam or not. Okay.
Okay.
So this topic is very much short, and mostly 99% they will ask about this value of h, that from which distance to that distance we need to measure h. So most of the questions are related to that. Okay. And if we talk about the value, that rho gh that we already discussed for the liquid, right? We know that gravity remains same for the air molecules, for the atmosphere also at the sea level, and we also get the value of h and the density of that liquid. We are using mercury, so we need to write the density of the mercury. And in ideal condition, so the atmospheric pressure that is calculated with the help of mercury, because we don't need to study about the procedure also, that how we calculate this atmospheric pressure. So that is also not included, so don't worry about that. We just need to know about the value of atmospheric pressure, but still the value of atmospheric pressure is given in your question. So we just need to know about the ideal condition, that what is the value of atmospheric pressure. So the value of atmospheric pressure in ideal condition is equals to, let's suppose we write, usually we write p naught, right? Because atmospheric pressure is natural, it will always there, right? We don't need to apply it especially, it will always there in the atmosphere. So that's why we use p naught for atmospheric pressure, and the value of p naught is equals to pascals or newton per meter square. So this is the value of atmospheric pressure in ideal condition or at sea level, we can say that. I will also write that sea level, because sometimes they used to ask about with the reference of sea level. Sea level means the atmosphere in which we are living and we are performing the experiment. Because with the atmospheric pressure, there is also a concept. Let's suppose if someone is moving at a very uh, extreme height, like he or she is just hiking a mountain, and on that height of that mountain, he or she wants to perform this experiment. So the pressure will be different at that level,
It will
right?
be higher, it will be greater, right?
Yes, so it will
Yeah.
depend upon the height also. That's why we are mentioning the sea level, the ideal condition.
So, sir, if in ideal conditions the height is 76,
Yes.
for a greater pressure, what would the height be? 74, 73, 80?
Yeah. If the pressure is very much high, so this height will be increased, right? Because you
Ah,
know that
okay.
if the pressure will high, so air molecules just push that liquid and your height will increase. So it will be like 78, sometimes 77, 76, but that is a very rare condition, right? Again, we are mentioning that we are performing in a lab. So in lab conditions are mostly like the same. So 44, 45, oh sorry, 74, 75, we are getting these value in lab experiments, right? Because in now a modern day we are having a digital machine for everything, right? You observe that there is a machine that we used to connect with the tire to check the pressure of that air in the tire, right? So that is also barometer, right? But that was not mercury barometer. Okay, that was the digital or the analog barometer. So that also gives you the pressure of the air in the tire, right? But that was not the mercury, because we are not able to use mercury barometer everywhere. So that's why after some inventions we got digital barometers and analog barometers to use for the purpose in our daily life. Okay, so that's why those topic was removed, because these topics are now very much old, and we are not using this experiment and these concepts in our daily life right now, because we have advanced application, advanced machinery, advanced apparatus to find out each and every quantity. Okay, so we are just keeping this topic at this level, because we need to also discuss. And you also know, let's suppose if we move at a very certain height on the mountain, so what do you think, that your pressure will increase, or the atmospheric pressure will increase or decrease?
Wait, can you repeat, sir?
Let's
Wait,
suppose if
yeah.
you want to hike any mountain or any
It
specific height.
decreases. It decreases. Because the particles get spaced out
Yes, because we
and less
take,
dense.
yes, we just take a very common example, like we are living at the sea level, right? Our normal life is at sea level. if we try to escape the earth's surface, right? So let's suppose if we just take a rocket and just we just move out away from the gravity of the earth, so in the space we are having no air molecules, right? So it means that less molecules are there in the upper part of the atmosphere. If we just consider atmosphere like this,
Wait, my bad, my bad.
no issue. If we take example of atmosphere, and I will also give you a very common example. If someone experience, let's suppose if someone observed that helium balloon, the normal helium balloon that kids used to play with, that we also used to play sometime. I don't know you play with that or not. So there is a normal air balloon and there is also a helium air balloon that is going to be filled with the cylinder. So let's suppose helium balloon will always in vertically upward direction. If we just tie a thread, so balloon will always be in vertical upward direction. It will not move in downward direction just like the normal air balloon, right? And you also observe that in some occasion or like some festivals, they use helium balloons to lift that banner or that flyer into the air. So why we are using helium balloons? And if you observe that
Because it's lighter than
yes,
oxygen.
it is lighter than the oxygen. So that is the important point, because at sea level, if we are talking about sea level, and if we talk about air, so air is more dense at sea level.
Wait, so I have a question. So if
Mhm.
there were like two villages, one beneath like a canyon or something, and then one on top of a mountain,
Yes.
uh, the people at the top of the mountain will be less fit, right? Because it's
Uh,
gonna be harder to breathe.
Yes. You can you also observe that their lifestyle are slightly different. Let's suppose if you want
Yeah.
to cook a food at sea level, so we use normal containers or normal saucepans and all the things to cook the food, right? But those are living at very specific height, like in mountainous area, just like in Pakistan at KPK, Balochistan, where we are having a very mountainous area. So if they used to cook a very normal food, normal meal, so they use pressure cooker, right? Because the pressure at that level is very much low. So atmospheric pressure will also
Uh-huh.
help to cook the food. So that's why they used to make food in pressure cooker, because that pressure cooker will help them to create pressure, great pressure in short time, right?
So
Otherwise,
pressure decreases as you go upward.
because at sea
Okay.
level air is more dense.
So it's the same thing as like a water bottle,
Yes.
the liquid pressure. Okay.
And if we talk about a very certain height, so that's why helium balloon will always move in the upward direction, because he is actually managing itself in that region where he founds the same molecules, right? So he that balloon actually moves in the upward direction till he just find the same molecules or the same surrounding, same atmosphere. So that's why helium balloon will not remain in at the sea level until we just forcefully place that balloon in that level with the thread, with the rope or anything, right? So at height, air will be less dense, and we are talking about air. So the last thing that we need to discuss about this height is, at height there will be low atmospheric pressure. High atmospheric pressure. There are some multiple examples of atmospheric pressure. We will also discuss that in next class, because now you got the concept of atmospheric pressure and this is enough, right, for our exams questions, right? But just for
Okay.
your interest and just for more clarification of topic, we will also discuss that example of suction cap, that why you also observe that in the car or on the windscreen of the car we used to hang something with that suction cap. So how that suction cap sticks on the glass, We know that there is.
Because the pressure inside it's a lot, I think.
Yes. So we also need to discuss some example just for your clarification of that topic. Otherwise, we don't need to discuss that one for with the reference of our exams questions, right?
Okay.
Let me show you some questions related to the atmospheric pressure in MCQs. So you may just solve that question by yourself.
Sir, I have a question.
Yes.
You remember the textbook we used to use last year?
Yes.
Yeah. Whenever there was like a star on the lesson, it was basically extended, right? We didn't need to study it for the exams.
Yes.
In my book, lesson chapter number 3, lesson 7, pressure from the air, it
Yes.
has that star symbol.
Actually, that addition might be the old one.
This is the fourth edition.
Okay, actually, that there is a star because I tell you that in our syllabus specification, we only need to discuss that specific value of H. We only need to talk about H, that how H help us to find out the value of atmospheric pressure, and we just need to know about the ideal value of atmospheric pressure. That's
There's
it.
no value of H here in the
Yes,
book, at least.
because in exam they never ask about the values also. They ask the question
Uh-huh.
like this, like the question number 62 in front of you. So that's why I'm just only explaining these things for your reference, because when I start the topic, so you just ask me first that any practical example, any experiment, how to find it, right? So for that purpose we are
Okay.
talking about this, because air molecules are not visible, so it is slightly difficult to understand that concept and difficult to digest that how it is possible, but still it is possible, right? We also discussed the
Okay.
example of human body that during running we feel high pressure, right? So questions
Okay.
are like the same value of H, like in 62 they are asking which height is a measure of atmospheric pressure.
Let's see.
Is it C? Okay, so C is the right one.
B. C is
Okay.
right. I
Yes.
don't know.
Okay, so actually we just measure, we just mark over here, just follow this white line that we draw for the H. So H actually started from the surface of the water in the container. This is the container and the top level in the tube. So with the
Sir,
reference
please
of,
send me the link of the
yes,
the
I will,
YouTube video for the mercury barometer. I'll watch it.
yes. So
Thank you.
that's why we use option C in this question. So questions are more likely to be this value of H, or mostly they ask about this depth question and height question, that at the depth pressure will be increase or decrease. We will also discuss in next class. But for the time being, you just only need to find the question related to that value of H. There are some more things. Yes, and this is example of manometer. This is also included in the old exam pattern, right? So now we also need to exclude this topic, because by using this example, we also used to find the pressure of some other gases, right? With the reference with the changing of height, you can see that height level is different, right? So this will
Yeah.
also help you to find out the pressure of some other gas, but that topic is also excluded.
Okay.
You can see multiple questions are related to manometer, but manometer is excluded. So your topic is already very short because of that concept. You can see again manometer. 51 is related to barometer. Okay, Amar, you may just leave the club. We are just ending this. I'm just showing
Uh,
question.
it's B, right?
Yes, again it's B, because we know from the top of the
So,
surface.
sir, what would you use the vacuum height for? Like this little height.
Actually, that vacuum, there is no use of that vacuum.
Okay.
There is only a concept of vacuum that you first asked me, that how we just make vacuum in the tube, because in our normal atmosphere, all air is always there, right? So that vacuum helps to understand that some mercury is added into the liquid bottom it, but still some, or we can say that most of the liquid is still in the tube, right? So that only gives you the concept that mercury, some of the quantity of mercury is added into the container, right? So that is the only thing. Okay.